All right, so we are supposed to identify the right-hand and left-hand behavior of the graph of polynomial functions. Okay, well, this is not on this test, just so you know it. This is from the old test. So what you're looking for here is you're trying to find the biggest exponent right here. So if you look, the number in front is a positive value, and the exponent is even. And if you look, it is an x squared, so you're supposed to know that the graph is going like this whenever you have a positive even, the ends are here and here. So what that's supposed to look like is as x approaches the left, infinity is. So as we go this way for x, the y values are going to positive infinity, they're going up. And as we go to the right for x, so as we go this way, this is the y values are also going up, so y is going up. That is called end behavior, and that's the end of that problem. Does anybody else practice 2, 4, 5, and 13? Oops, I got another person wanting in here, so let me get them in. Okay, so we're going to go do practice test 2, 4 to 2, 5, number 5 and 13. And I think I already did 13, but I think I did that this morning. So let me look here. I'm going to look on my Canvas page here real quick. Okay, I did not do 13. All right, so we want 5 and 13, so we're going to film that. So let me find the correct number 5 and 13. We're not talking about the 5 on this page, right? We want the 5 on the other page. So let me find this thing. Okay, let me go this way. Is that the right number 13 right there? Is that the 13 you want? Give me a yes or no. None of the other 13. Okay, let's see if I can find that 5 and 13. And let me go back here again. Let's see, that's not it. Okay, is that the right number 5? Okay, so we got to find the other 5 and the other 13. So let's see. All right, there's the 5 we want right there. So we're going to do this number 5. It says sketch the graph more accurately using the roots of the function. So that means the zeros. And we want this function of x cubed minus 8x squared minus x plus 8. We're supposed to do the p over q's. P is the factors of 8. So factors of 8 are 1 and 8 and 2 and 4. 2 and 4. Oops, those are the factors of 8. And then Q is the leading number. This is Q, and the factors of 1 are 1. So I've got to put all 4 of these divided by 1. So when you do, and you put plus or minus, so you got plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So you are supposed to try to find the factors of these. Okay, and we want 0. So I'm going to try 1 first. So if I put 1 in and I do synthetic division where I got 1, negative 8, negative 1, 8, I am looking for this remainder to be 0 right there. So I'm going to bring the first number 1 down. I take 1 times 1 and stick it under there, and I get negative 7. 1 times negative 7 is negative 7. That gives me negative 8 there. And 1 times negative 8 is negative 8. That does give me 0. So one of my roots is x equals 1. Which tells me there's a dot right there at 1. Then I'm supposed to factor or try to solve this thing, but now it's a quadratic. So now I can factor it just like we do with the t-chart. So I take 1 times negative 8 and get negative 8, and I want to get negative 7. So I need factors of negative 8 to give me negative 7, which will be negative 8 and 1. So that means this factors to x minus 8 and x plus 1. Now there's a 1 in front here, so that doesn't change putting that under those. So then you got to set x minus 8 equals 0 and x plus 1 equals 0. So we get x equals negative 1 and x equals 8. So those are my roots, 1 negative 1, and 8. So I'm going to come out here to 8 and put a dot. I'm going to put a dot at negative 1. Now I'm supposed to get my y-intercept. So that means I got to plug zeros in for all the x's. So 0 cubed minus 8 times 0 squared minus 0 plus 8 will always just give me the constant. So my y-intercept is 8. So I come up here to 8 and I put a dot. Oops, I got more people wanting to come in. They're late. Okay, so in behavior, so if you look, I have a positive cube. So we're supposed to know positive cubes are like this. So as x goes to the right, that's this way, y goes up. And as x goes to the left, that's this way. As x goes left, y goes down. So I can tell from looking at this that this graph is going down this way. It's going to come up here and it's going to touch this dot right here, and it's going to come back down, and it's going to come down here. Now, you can put a number in here for a t-chart. Like I could do x of 5 and calculate that number, whatever it is. But I know if I put 5 in there and cube it, that's 125. Wait a minute, that's the wrong formula. It's this formula right here. So that's 125 minus 25 times 8. That's 25 times negative 8 is negative 200. So this is negative, and that's negative, and plus 8 doesn't get it back up. So I know it's going clear off the graph down here somewhere. I don't really care where, but that is what that graph is going to look like. And I don't think you have one exactly like that on the test, but you have one similar to that. And now we want to find the other number 13. So let me find the other number 13, which should be this way somewhere. We said that was not, wait a minute. Yeah, that was not it. So we're talking about this one, is that right? Just to make sure. Okay, so first thing you notice, or I notice, is there's a negative in the radical. So whenever you have a negative in the radical, you get rid of that negative in the radical by putting an I outside. So that's the first step. Bring the I out to get rid of the negative inside. The square root of 49 is 7, and I am now done. Are there any other problems anybody wants to see? For you guys that all came late, if you go to Canvas, today's page of Canvas, at the very bottom in the middle, I've got the key to all the practice test answers, so you can check them out. There's also videos on Zoom right now that you can watch. So again, I'm going to bring this back over here. Oops, wrong one. So if you look right here, here's the key to both practice tests. And then here's a video that's got 7, 8, 11, 15, 16, 19, 1, and 2 worked out right here from second or third period. And then I'm also going to put the video of these problems on there too. All right, we got number 9. Number 9 is one we want to do. All right, so I'm going to get this thing back over here. Number 9. Okay, so you got to tell me which 9. Is it this 9 right here? That 9 right there at the top? No, the other 9. So let's see if we can find the other 9. There's the other 9 down here. Okay, so I already did this number 9, although I don't know if it's online, so I'm going to do it again. So this tells me that this is a 0 right here. And we're supposed to know from class, I told you the other day in class, that if you have an imaginary number, that they go in pairs, so the conjugate of negative 3i, 3i is also a 0 on this function. So there's 2 of the zeros, and since that's a 3, that means there's only one more 0 to find. So I'm going to use synthetic division. So I'm going to stick negative 3i in my box, and I'm going to write down my coefficients from up here. And I already know, since this is a 0, that when I get to here, that's got to be a 0. If I don't get a 0 right there, I've made a mistake. So we take this 2 and bring the 2 down. I'm going to make this writing skinnier because this takes some room. Then I take negative 3i times 2, and that is negative 6i. Well, 3 minus 6i, those are not like terms, so I got to keep them separate. And now I got to take negative 3i times 3. Well, negative 3i times 3 is negative 9i. And then negative 3i times negative 16i is 18i squared, which this is a negative 1. So that means this is negative 18. So this is the real part, negative 18. So I hope you see that 18 and that 18 cancel, and I'm left with negative 9i right here. Then I take negative 3i times negative 9i. Well, that is 27i squared. And for the same reasoning, that makes this negative 27. So there's one of my zeros right there. And since they go in pairs, imaginaries are in pairs, I'm going to do this 3i. So I'm going to stick 3i here in the box. And I'm going to do the same thing. And I already know I'm going to get a 0 right there. So I bring the 2 down. 3i times 2 is 6i. Well, that negative 6i and that 6i cancel out, so I'm left with 3. 3i times 9 is 9i, and you can see these cancel. So what that tells me is that what's left here, remember that was a cube, so this is a square, so this is the first power, so that means 2x plus 3 is what's left right there, and set that equal to 0. And I subtract 3, and I divide by 2, and I get negative 3/2. So all my x values here are x equals negative 3/2, x equals 3i, and x equals negative 3i. So those are my 3 zeros. Now I said find the other zeros, so you didn't have to put the negative 3i, you got to put those two. But if you put the negative 3i, I'm not counting it wrong because it is a 0 even though they gave that one to you. Does anybody have any other questions off this? Okay, so if you're not asking more questions, I'm going to call it a weekend. Last chance. All right, well, have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see all of you Monday and Tuesday for the test.